Hello everyone and welcome to this video on the Python programming language and machine learning. So in this video, I'm going to show you how to create a program that predicts employee attrition. Now currently I'm on Google's website called colab.research.google.com because it makes it really easy to start programming in Python. So all you have to do is go to that link and then log in using your Google account and get started writing your code. So let's go ahead and get started writing this code now. So the first thing that you're going to want to do is click on File and then click on New Notebook where a new tab will open up for you and a new cell. And in this cell, I'm going to put in comments a description about the program. So let's do that now. I'm going to type description, and I actually want this to be a capital D. Okay, so this program predicts employee attrition. Now I'm going to create a new cell by clicking this code button in the top left. And in this cell, I'm going to import the libraries that I know I will need throughout this program. So I'm going to import numpy as np. I'm going to import pandas as pd, and I'm going to import seaborn as sns, and I'm going to run this cell by clicking this button here to the left. All right, hopefully there are no errors. All right, it's trying to connect. All right, good. So let's go ahead and create a new cell. And in this cell, I'm going to load the data. So I got this data set from online. It's IBM employee data. And I'm going to use Google's library to load this data. So from google.colab, I'm going to import files. All right, and I'm going to create a variable called uploaded and set it equal to files.upload. Okay, and let's go ahead and run this to upload the file. Click choose files, and I'm going to choose this file here. So let's click open, and now it's loading and it's done. So let's create a new cell. All right, and in this cell, I want to store the data into a data frame. So I'm going to create a variable called df, which will be short for data frame. And I'm going to set it equal to pd.read_csv, and I'm going to input the name of the file. So I have it here. I'm just going to highlight it and then click Control C for copy and Control V down here to paste it. And then I want to print the first 7 rows of data. So just type df.head and then input the number 7, and let's run this cell. Okay, so now we can take a look at our data. So we see the age, we see attrition, which is our target column that we're going to try to predict. And let's look at some other columns and their values. So employee count, it looks like it's all ones for some reason. Employee number, which I'm guessing is the ID for each employee. Let's keep going over. All right, so we see job role, job satisfaction, marital status, monthly income, monthly rate. We have over 18 here, which looks to be all Y values. So I'm assuming that this column here checks to see if the employee is over the age of 18. And my next assumption is that every employee is over the age of 18. All right, so we'll probably have to check these columns. Let's see, percent salary hike, performance rating, relationship satisfaction, standard hours, standard hours looks to be one single value, 80. All right, total working years, training time last year, work-life balance, years at company, years in current role, years since last promotion, years with current manager. And that looks to be it. Okay, so just from looking at this data set, I already see about 4 columns that I think are useless. So anyways, let's go ahead and create a new cell. And in this cell, we're going to get the number of rows and columns. So just type df.shape and let's run this. And now we can see that we have 1,470 rows and 35 columns. Or another way to say this is that we have a data set that contains 1,470 employees and 35 data points on each employee. All right, so let's go ahead and create a new cell. And of course, some employees are no longer with the company and other employees are with the company. That's what we're going to try to predict, right? So I want to know the data types of the columns. So here we're going to get the column data types. So just type df.dtype. I think it's dtypes actually, yep. And let's go ahead and run this. All right, and now on our left we have our column names, and on the right we have the columns data type. So let's go ahead and create a new cell. And in this cell, I want to get a count of the empty values for each column. So in order to do this, I'm going to type df.is in a and then .sum. All right, let's run this. Okay, so again, we see the column names on our left and the count of missing values on our right, which seem to be all zeros. So let's just double check this. Let's create a new cell. And what we're going to do here is we're going to check for any missing or null values in the data. So just type df.is_null and then .values.any, and let's go ahead and run this, and we get back false as expected because we didn't see any missing values. This is just another way to check. So let's go ahead and create a new cell, and in this cell I want to view some statistics. All right, so just type df.describe, and what do I mean by statistics? I mean things like the maximum value, the minimum value, the percentile, the mean, the standard deviation, things like that. So let's go ahead and run this cell. All right, so now we can see some statistics for each of these columns. So for example, age, the minimum age is 18, which I kind of expected it to be, and the maximum age is 60. All right, and let's look at hourly rate. So we can see that the maximum hourly rate is 100 and the minimum hourly rate is 6. No, that's the mean. Wait, yeah, that's the mean. So the mean hourly rate is 65.89 and the minimum looks to be 30. All right, so the mean is 65.89. Okay, so we can keep looking at some more stats on each of these columns, but let's go ahead and move on for now. Okay, so let's get a count of the number of employee attrition, or maybe I should say get a count of the number of employees that stayed and left the company. All right, so in order to do this, just type df, and then we want the attrition column. So attrition, and then just type .value_counts, and let's run this. Okay, so now we can see that there are 1,233 employees who are still currently at the company and 237 employees that have left the company. Now let's go ahead and create a new cell and let's visualize this. So here we will visualize the number of employees that stayed and left the company. So in order to do this, just type sns.countplot, and we're going to input df attrition. All right, so let's go ahead and run this. And now we can see a visualization of those numbers. So it seems a bit lopsided. So I'm very curious if the model that I'm going to create, the machine learning model that I'm going to create, if it can do better than just guessing no all the time. So let's go ahead and see if our model just guessed no all the time, what's the chances of it being correct? So I could take these two numbers, which is 1,233 plus, was it 237? I think it was. Let's go back up. Yep, 237. And then I can divide that by 1,233. And if I were to just guess no all the time, or the model was just to guess no all the time for attrition, it would be, sorry, I put plus instead of minus. So that's 1,233 minus 237, right? Okay, so let's run this again. So the accuracy will be 80.77%. Okay, so just by guessing no, the model could, just by always guessing no, the model will be 80.77% correct. So I want a model that has a higher accuracy than that. All right, so let's go ahead and create a new cell. And let's see what I want to do here. Let's take a look at some of the data. Let's kind of analyze it a little bit, right? So I want to show the number of employees that left and stayed by their age. So I could just type sns.count plot, and the x value will be their age. The hue will be attrition, and our data will be df. And then I'm going to use a colorblind palette. So palette will be equal to colorblind. Okay, and I think that should be good enough. Let's go ahead and run this. All right, so that looks good, except I can't really read these numbers. So let's make this look a little bit better. So I'm going to import matplotlib.pyplot as plt, and I am going to, let's see if I can just type plt.subplot. Maybe I can change the figure size. So the figure size will be 12,4, because I want the figure here to be a little bit longer this way, you know, from left to right. So let's go ahead and run this. Okay, so that looks good. That looks a lot better. And so if we analyze this a bit, we can see that if the person was 35 or 30, well, let's see, 35 or 34, a lot of those people that age are currently employed. And I can see between the age of 29 and 31, it seems like it's the majority of those people at that age actually left the company. So that's pretty interesting. All right, so let's go ahead and create a new cell. And actually, let me go back up here. I want to just kind of comment this here. And I want to put, this is the percentage if we just guessed no. All right, for attrition. All right, I think that's good. Now, I want to print all of the object data types, and I want to print their unique values. So let's do that now. Print all of the data types and their unique values. All right, so for column and df.columns, if that column's data type is an object, then we're going to print the column name, and I want to print the columns. I want to print the column's unique value. Okay, so hopefully I didn't make a mistake there. Next, I want to print the value counts for each column. So just type df column dot value underscore counts. Okay, and then I'm just going to print like a little line to keep track of each column. Okay, so let's go ahead and scroll up and let's run this. All right, no errors. Okay, so now we can see every column that is an object in our data set, and we can see the unique values for each. So we have attrition here, and we can see the unique values are yes and no, and then we can see the value counts for each, kind of like what we did before. But now again, I'm doing this for all of the objects. And of course, we can change it up. It could be just for any data type column, but some are going to have a lot of numbers, right? So I didn't do it for any of them. I only did it for the object. But let's see here. The column over 18 does only have one unique value, and that's Y. So I definitely want to get rid of it. I'm wondering why it's here. So let's go ahead and create a new cell. And let's start removing some columns. So here we will remove some what I think are useless columns. All right. So one column I want to remove is the over 18 column. So df is going to be equal to df dot drop, and I'm going to drop over 18 column because all of the employees in this data set are over 18, and we need to drop it on the axis 1. So that's how we know that we're dropping it on the column. Okay, we should probably actually check for the other columns, but one column I know I want to drop is the employee number. So that's df dot drop employee number. So axis is going to be equal to 1, and I need to check for these other two columns that I want to drop. So I'm going to create a new cell actually here, and I'm going to type df, and I think the column name was standard hours, and I want to see standard hours unique values. Okay, so let's run this. All right, so it only has 80, right? So that's another column I want to drop. I'm just going to copy this down here. Oops. So that didn't work. Let's try to copy this here. There we go. So that did work there. I want it to be standard hours. Standard hours. And then the other one I wanted to check, if I can remember the name, I think it was employee count. So let's run this. All right, yeah, employee count only has a value of 1, so I don't think we need that either. So let me copy that, paste it, and we're going to remove employee count. Okay, so I'm going to go ahead and get rid of this. But now you all know why I'm removing these columns, right? They don't really bring any more information to the data. All right, so let's go ahead and run this. Okay, and let's create a new cell. And now let's get the correlation. So just type df.core and let me see, left parentheses, right parentheses, and let's run this. Okay, so now we can see the correlation for each column, which it really kind of looks a mess, really, to me. It doesn't seem very visually appealing. So let's create a new cell and let's visualize the correlation. All right. So in order to do this, just type sns.heatmap, and we're going to input df.core, and we're going to annotate it. So annote is going to be equal to true, and then we're going to format it. So fmt is going to be equal to a percentage with nothing behind the decimal place. All right, and let's run this. Okay, and that doesn't look that good. So let's change the size. plt.figure. We're going to give it a figure size, and it will be, we'll do 14, 14. And let's run this. Okay, that looks a lot better. Okay, so let's take a look at this. One thing that's pretty interesting is, I don't know, it just really pops out. It looks really good. We can look at the age column and we can see that it has a positive correlation, 68% positive correlation with total working years. And that kind of makes sense, right? The longer you're working at a job, the older you're getting. Kind of makes sense. And here, job level has a 78% correlation with the total working years. So I guess, maybe the longer you work at a job, the higher your level is, right? Because you know more information, you know more about the job. So that kind of makes sense to me too. Here we have monthly income, and it has a 77% with correlation with total working years. So I guess, the longer you're working, the higher your income at that position. And what's interesting, there's a 95% correlation here. So let's see, that's monthly income with the job level. Okay. So the higher your job level, the more money, or the higher your monthly income is. So this all makes sense. I think it makes sense. All right. So enough exploring that. Let's now start to transform the data to get ready for our model that we can make predictions on. So let's go ahead and create a new cell. And here we're going to transform the data. All right, so what do I mean by transform the data? I want to transform non-numeric columns into numerical columns. So I put that here, transform non-numerical into numerical columns. All right, so I'm going to use another library. So from sklearn.preprocessing, I'm going to import label encoder. All right, so let's encode all of the columns that are not numbers. So for column in df.columns, if that column's data type is a number, then we won't do anything. We'll just continue. But if it's not a number, then we're going to encode that column. So that column is going to be equal to label encoder dot fit underscore transform and then we're going to transform that column. All right. So let's go ahead and run this. All right, no errors. Let's create a new cell. And in this cell, I'm going to create a new column. And so you may be wondering, why am I creating a new column? And that's because when I looked at the data set, I'm going to create a new cell here and just type df to see the data frame. We can see the age column here, and I really want the first column to be attrition. It just helped me when I'm splitting the data. So let's go ahead and delete this cell. So I'm going to take a copy of that age column. So I'm going to create a column called age underscore years. I'm going to set it equal to df age. And let's run this. And then I'm going to drop the age column. So df is going to be equal to df dot drop, and again I'm dropping the age column. So the access is equal to 1, and let's run this. And then let's create a new cell and let's show our data frame. All right. Okay, so now we have the attrition column here, and if we slide over, we now have our age column here, but now it's called age years, but still the same data. All right, let's go ahead and create a new cell, and let's see, now I want to split the data. That's the whole reason why we did that, right? So let's split the data. So we're going to split the data into independent X values, or independent X data set, and dependent Y data set. So I'm going to create a variable called X and set it equal to df dot ilock, and I want all of the rows, and then I want all the columns from column 1 to whatever the last column number is. So let's see, that's the shape of df at position 1, and then I want this to be a array, so I'm typing dot values here. And then I'm going to create a variable called y, so this will be our y data set, and we're going to get all of the rows from column 0, and I want this to also be an array. All right, so let's run this, and let's create a new cell. Now I'm going to split the data even more. So I'm going to split the data into 75% training and 25% testing. All right, so I'm going to use another library. So from sklearn.model selection, I'm going to import train test split, and let's create some variables. So x underscore train, x underscore test, y underscore train, and y underscore test. Okay, I'm going to set this equal to train underscore test underscore split, and we need to give it the data sets. So that's x and y, and then we need to tell it the test size. So the test size is 25%, so we're going to type 0.25, and then I need to give it a random state. So I'm just going to give it a random state equal to 0, and let's run this. All right, let's create a new cell. And the model that I'm going to be using is the random forest classifier. So let's use the random forest classifier. That's the algorithm that we're going to be using. So from sklearn.ensemble, I'm going to import random forest classifier. So I'm going to create a variable called forest, and I'm going to set it equal to random forest classifier, and we need to give it a few parameters. So the number of estimators, and I'm going to set that equal to 10, a criterion criterion. So I'm going to set that to entropy. And then the random state that I'm going to give it will be the same value that I gave when we split the data. All right. Next, I want to train this model. So just type forest.fit, and we're going to train it on our training data set. So that's x train and y train, or x underscore train and y underscore train. And let's run this. All right, let's create a new cell. And now I want to get the accuracy on the training data set. All right, so I just type forest.score and then x underscore train and y underscore train, and let's see how good our model did. All right, so our model is about 97.9% accurate on the training data set. All right, I'm going to go ahead and create a new cell, and now I want to show the confusion matrix and accuracy score for the model on the test data. So from sklearn.metrics, I'm going to import the confusion matrix, and I'm going to create a variable called cm, which will be short for confusion matrix, and I'm going to set it equal to confusion underscore matrix, and then I'm going to give it the test data, so y test, and our model's prediction. So that's forest.predict on the test data. All right. And then I'm going to create a few more values. So TN will be short for true negative, and I'm going to set that equal to CM at position 0, 0, because that's where it's located. Our true positive is located on our confusion matrix at position 1, 1. Okay, the false negative is at position 1, 0. And the false positive is at position 0, 1 on the confusion matrix. Okay, next I'm going to go ahead and print the confusion matrix, and I want to print the model's accuracy. So here I'm going to put model testing accuracy equals, and then I put dot format, and we can calculate the accuracy here using the confusion matrix. So just type TP plus TN, the true positive plus the true negative, divided by the true positive plus the true negative plus the false negative plus the false positive. Okay, and let's go ahead and run this. Okay, so now we can see the confusion matrix being printed here, and we can see that the model was 86.4% accurate on the test data, and that is better than the 80% that we got just for guessing no for attrition. So I really like that. All right, so that is basically it. I really hope that you all enjoyed this video. Please leave any questions you have in the comment section. If I don't get to them, maybe other people will. Don't forget to become a subscriber to my channel. And if you're really interested in machine learning and Python, I have many more videos on this channel that you can check out. So be sure to look at those and view those. And if you found this video helpful, please share it. Maybe others will find it helpful. And as always, thank you all for watching, and I'll see you all in the next video.